Thank you very, very much, everybody, for such a lovely, warm welcome from everybody. Um I am honored to be here, and as the ethos of focus, it is important to bring together everybody and talk today about uh, several aspects, but all of them leading to a singular goal of safe and long lasting buildings or safe and long lasting infrastructure. And today and in the times to come, me and Liaquat Ali will be focusing heavily on increasing the awareness related to fire safety. And we would all bring together our experience of so many years put together about so many aspects related to fire safety, whether it is electrical products, building materials, switch gear, or so many aspects. A quick check. I believe you can hear my voice.
Yeah, very good.
Perfect.
Yeah, loud
So
and clear.
let's begin with understanding, and I'm going to talk about fire safety. And let me break the myth to all of you that it is not always Professor Dumbledore who gets the fire into a building. It is actually small and minor accidents that sometimes become a very, very big fire incident. And our focus is to make sure that in all the aspects that are related to all the stakeholders of building and construction, we make sure that these small fire incidents do not become a big fire accident. And all of this is actions and thought correctly put at every stage, right from designing, when we are designing something, including building and construction when the construction is being done, and right up to when we are furnishing, planning, demarcating, rebuilding, as well as the occupant who comes in and wants to live, wants to occupy, and say, wait a minute, I want this here, I want this there, all through the life cycle of the building, right from designing or dream stage, as I would call it, and right up to occupation. There are several aspects where fire safety and other aspects of longevity and quality of a building come into practice. Now, very often, it is easy for us to say, well, the building is designed as per the code, the building code. But it is extremely important to question and understand throughout the four phases of design to occupation that are these codes current? Are these updated? Are these codes factoring in some of the learnings, some of the accidents, some of the failures that we might have seen just a few months ago? We all know that the problem of lag in change of codes, change of mandatory regulations in every country exists. Every country exists. And this is the reason why it is critical and important to have additional technical specifications, which are often written for all the projects that you can think of or bid for. So once we have this backbone ready, we have a code which has been published with decades and decades of experience of people in a given area or all over the world, but also airports, malls, large occupancies where international consultants are involved who bring in their learnings from past accidents would always bring forth the latest, the current requirements in the form of technical specifications. So today, one of the key areas which I will be talking about is applicable throughout the focus areas is compliance. And this is extremely important for ensuring that whatever is getting built, whatever is getting constructed is being checked. There is defined liability of the main contractor, subcontractor, subcontractor, material supplier, consultant, project management company, because the checker needs to be independent. The checker needs to be qualified. He should be able to distinguish. And there is a legal linkage to all these aspects, because when something goes wrong, someone has to be punished and someone will have to pay for it. So all these linkages are always created with the contract, and hence everybody throughout the course of the construction project, whether it is the architect or the finance manager or the legal guy or someone who is writing the contract, all of you should be aware of these concepts. With this as a background, let me start with explaining and giving my experience of how is fire safety achieved across the world. Across the world, the concept of fire protection, which starts at the design phase when people are planning the fire and life safety plan of any construction, they want to make sure that if there is a fire accident that happens, let's say, as you can see in the video running on the top left of your screen, it is designed in to make sure that this fire does not grow into a big accident. And how is this done? The two concepts are everywhere in the world. What is called as active fire protection. So all the components, systems that come into action, that come into activation, whether they are detectors of fire, smoke, or sprinklers who get activated the moment they sense a fire and raise an alarm, call the fire tender, evacuate everybody. All these systems which need to function properly are called active fire protection systems. And another equally important and sometimes not given as much importance are passive fire protection systems. What are these passive fire protection systems? Well, the concept is that if there is an initiation of fire anywhere in the building, in the house, on the floor, it should be quickly contained and compartmentalized in the section where the fire has happened so that the fire does not grow and escape all around. This concept, which I will explain further, along with making sure that the interior finishing materials, the fire load or the products and components and systems like upholstery and other things which are inside do not react quickly to increase the fire and make the smoke grow. So as we talk about containment, we talk about limiting the ignition, limiting the spread, as well as a very, very important aspect of structural fire protection, which means that the structure of the building should not lose its integrity if the fire temperature around the structure goes more than, let's say, 500, 700, 800 degrees, and the structure does not collapse, almost like the 9/11 tragedy that happened. So how do we really check that this compartment image on your screen? There is a fully developed fire in one of the rooms, but because the compartmentalization has been done so well, the fire is not escaping into the adjacent or the floors above or the floors below. This concept of compartmentalization is the key to passive fire protection. So how do we really check that this is getting done? We start with, of course, having a test. We would test the compartmentalization by using a fire furnace. what you see on your screens is part of our fire testing lab. And this furnace recreates a scenario, it recreates an environment of a fully developed, fully grown fire. And with the help of this furnace, we are able to check by installing a compartment or a mock-up of a compartment. This could be a fire door, it could be a wall, it could be a damper, it could be a duct, it could be a fire stopping, and one of several different aspects of building and construction, which ensure that the compartment which has been designed and installed correctly is maintained for the given duration, which could be 1 hour, 2 hours, or 3 hours, enough time as per the design to evacuate the complete occupancy, get the fire tenders in who will control the fire. Now, while we know that this is how a fire test could be done in a facility or in a laboratory like ours, it is very important to know and understand that what happens when you conduct a test, because you can conduct a test of a mock-up of a door or a partition, but what is this built of? You would have wooden planks, you would have gypsum boards, you have so many aspects that come together and build a fire partition. But often these are manufactured in a manufacturing location. These are installed at the site. So how do you make sure that what the test has been done in the laboratory and you see a test report on your table, is it representative of what you will get on the site? What links the test report with what materials that are coming in at the construction site? And this is the key across the stakeholders of the construction process, and from one end where you have the National Building Code or the technical specifications saying materials, components need to comply with certain test methods. How do you make sure that a given test report, which is done in a given laboratory, is representative of what is happening and what is being installed at the construction site? And this is where I take up my first case study very quickly, that how do you ensure, with an example of a fire door, that all aspects, design, components, materials, which were listed in a test report are the same as what is happening on the construction site. So one of the very tedious approach which some projects take is that for each construction happening, the subcontractor or the consultant will select certain doors and randomly send them to the lab and do these tests. And then there is another approach, which is the supplier approach. There is something called certification and listing. And this certification and listing, which is often done to ensure the repeatability of offering of the manufacturer's facility is audited regularly. And what this audit typically results in is that it results in a verification or an assurance that each time a door manufacturer or a board manufacturer or any product manufacturer produces a given product, its details can be verified on an online certification directory. And this certification directory, whose details are often linked with a certification mark, the label, which could have a traceability, will list every aspect which can be verified at the construction site. In the small video that is running on the bottom left, you can see the listing of a fire door that we have certified to comply to the UL standards or the North American standards. And all the details of the door are made public. All of you can review this at the certification directory, which is tbwcert.com. And not only can you verify that the certificate is current or not, it will verify that the certification body or the auditing certification body is going to audit the factory regularly to make sure if there is a label on the door, all the details are public and you can, from the construction side, cross-verify. And this is the level of assurance that is needed now and is mandated in most of the countries. Moving to one of the hottest topics of today, which is facade or cladding fire safety. A very often ignored aspect is that the whole facade which is built can be represented by just 1 or 2 tests. And that may not be the case. You could do some material tests and validate the material behavior, which could be the facade element, it could be the insulation material, it could be the sealants, and so many other aspects, which you could test for ignition or flame spread as an independent material. But it is equally important to know and understand that in every building facade, there are sometimes, if not a few dozen, but sometimes hundreds of different details of design where components, materials are making different subsystems. And these specific subsystems need to be validated by doing sometimes several mock-up tests, not just one, but several mock-up tests as large-scale fire propagation tests. So in a quick summary, to ensure that the cladding system is fire safe, it starts with the fire consultant, the facade specialist, the contractor doing a risk assessment, checking various reaction to fire properties, and not just by tests, by ensuring that there is a traceability of materials using certification and listing, and evaluating which all sections of the facade of the building envelope are high risk, because those components and materials which have low ignition temperature, high calorific value, very high flame spread could be coming close in a given section of a facade detail. And these need to be mocked up and validated and ensured that they will not cause a big fire accident. But this validation is not the last step. Someone needs to check at the construction site, inspect that what has been certified is what has reached the construction site. As you can see on the image, the back of an aluminum composite panel, which reaches the construction site, has all the details with the help of a ticker tape. The number is written. If you track the number, you can look at the certification directory and not just look at the fact that whether the certificate is still valid or not. It will detail what the product would look like, what are the components, and if there is a mismatch, it means you have been cheated, that someone has given you a different test report or a certificate and supplied you a different material. And this core concept remains the same across all products. So with this, I will end and pass to my colleague, Julian, who will talk a little more about how other properties of the facade are very important. Over to you, Julian.
Thank you, Abby. Thanks for that. Very good, very informative. Just want to say that it's a real honor to be with all of you guys today. And I feel sort of privileged to be able to speak in such an esteemed company. I'm going to be talking about changing facades. So let's see, let me get the screen up. And hopefully you can see the presentation there. Okay. With changing facades, fundamentally, we change facades for 2 reasons. Aesthetics is very much a main thing that we look at first. But then we also have to consider function and the function of the facade, what we expect from it, how we expect it to perform. Has anything changed? Well, yeah, a lot has changed. We started with wood and straw walls. That was our facade. Functionally, it worked very well. It served a purpose. As time's gone on, we've experimented with other materials, whether it be timber, stone, brick, concrete. But as you can see, with mud and straw, we moved on. The aesthetics weren't great. We moved on to other materials. With concrete, sometimes grey and quite dismal, but at times we've tried to use that material as well. And that has been used back in 1962 for the Palace of Assembly at Chandigarh. So there's always been this desire to make what we do and what we create aesthetic and look aesthetically attractive. It's a fact that if a building is more attractive to look at, it will have a higher sale value. It'll attract more leaseholders. Its value will be more. And as time has gone on and we've gone through the changing aesthetics, what we have is this influx, if you like, of new materials, which has enabled us to create some wonderful structures and wonderful buildings. We've used these materials to give a dramatic impact, if you like, to facade systems, ensuring we're attracting the right kind of people to our buildings, people that will pay a good rate for leasing, for purchasing the buildings. Developers like it. Developers want to make their buildings unique. They want to make them stand out from the crowd, and we'll look to experiment with different materials and different structures types. But one of the things we have to take into consideration, and it's what I said earlier, is that changing facades is about aesthetics and function. So whereas it's great to use these materials to develop these interesting facade systems, if the function is not there, for example, what I mean by that, say we've got a building that we've got a lot of air leakage issues because the facade hasn't been designed and assembled in the correct manner. What we're doing is we're leaking out air, we're air conditioning inside the building, and then we're actually losing air as it escapes into the atmosphere through the facade. That impacts on costs because costs go higher. It impacts because our energy consumption goes up. That impacts our whole purpose of sustainability. That impacts our whole purpose of trying to be environmentally friendly in what we do in the construction industry. So we have to make sure that in our desire to create more attractive facades, we don't develop issues and we don't sacrifice function. We don't have areas where doors don't fit properly, where windows don't fit properly, which allows the air to escape from the building. We don't have situations where water leakage, water penetration makes the building unattractive. People don't want to live in a building that leaks. It's very simple. And then what we don't want as well is this condensation issues. We don't want this water getting into our frames, discoloring the frames, early corrosion on some of the systems. So we have to make sure that the function of the facade performs as it should. With all this technology that comes along with all these materials, it's often the case nowadays, which a lot of the major projects will look at a facade specialist. Facade specialist, you go back maybe 30, 40, 50 years ago, didn't really exist, but now they're needed. And it's important that we bring in facade specialists to look at the design, to look at the function of what we're doing with facades. It's a very important issue that what we look at with facades, it's the detail, and that's what often gets missed. It's the detail of what we're doing. The facade looks great. It might look like a simple piece of material, but how does it fit? How are we fitting it? What materials are we using? it's interesting that with materials, we embrace new materials. We want to put them all together. My colleague, Mr. Mutaz, will go through a case study which very clearly illustrates that sometimes materials aren't compatible. Sometimes materials don't go together. So whereas we want to embrace these new materials, whether it's titanium, whether it's solid aluminium, PTFE coated glass fabric as used on the Burj Al Arab here in Dubai, or it could even be rubber, recycled rubbers being used. These are all materials being used for facades, but we have to look at how they fit together. And often that is what gets missed. And that gets missed, and then we have functioning problems with the facade system. Now, one of the key things with new materials, one of the most important aspects really that we need to look at and we need to be cognizant of is fire. We need to make sure that whilst we're developing and designing attractive facade systems, that they're not going to spread fire, that we're not going to have issues. And the only real way that this can be addressed is through fire testing. Now, I'm not going to labor on this too much because Abhishek has said quite a lot about with regards to fire testing. But with facades, when people get enthusiastic about new materials, that's great. That's what we like. We like to see that. But at the same time, you've got to take into consideration, what is the impact? We have a responsibility. We have a responsibility when designing and building buildings that the occupants of those buildings are not at jeopardy and not at risk. And so it's imperative that with the new materials that we like to bring in with our facade systems, that we do look at the fire implications. Now, typically what a lot of people look at these days is curtain wall systems for facades. And typically the first thing you would look at, are we going to use a unitized system or are we going to go with a stick system? These are systems which are very much determined by the size, the stature of the building that you're working with. But an integral part of the curtain wall system is the glass. And the glass is moved on very much from what was a basic format, if you like, many years ago. We've got double glazed and triple glazed windows nowadays. We have tempered and laminated glass. We've got glasses with various tints, self-cleaning glass, glass you can walk and jump on, glass that's curved and shaped. And nowadays, we even have smart glass, which detects the UV that's coming into the building and adjusts itself accordingly. Architects like glass and they like to work with it. It enables them to create some iconic buildings, enables them to create beautiful shapes for the buildings. So whilst it's nice that we have all these options with glass, again, what about the functionality? Glass will have a thermal insulative impact straight away on the building. So without the right glass, what happens? The building gets too hot. The air conditioning has to work harder. The costs, the operating costs for that building, the utility costs start to increase. There's an energy impact there. Again, we're using more energy. The sustainability comes into question. Have we built an eco-friendly, an environmentally friendly building? Well, no, because if we're using too much air conditioning, then no, we're not. So it's very important that when we're dealing with facade systems where there is a lot of glass, that we consult the right people, that we consult the right manufacturers. Again, this is what a lot of people will go to a facade specialist for, to basically say, what is the best sort of glass I should be using? How should I integrate the glass? Having the glass is one thing. Having the design is another thing. Assembling it, putting it together, manufacturing it to a standard that allows the facade to perform as it should. It's critical. It's critical. In the past, and we've seen it ourselves here in Dubai, people take chances sometimes and they'll throw a facade up and then they'll have huge problems. They'll have problems with the glass is cracking. It's been installed for a year, but the glass starts to crack. You have instances where gaps start to appear in the panels and the joints, where the sealant starts to erode very quickly. So there are a lot of instances where things go wrong that we don't expect to go wrong, but that's because they haven't taken a studious approach, if you like, to the design of the facade system. So whereas it's nice to change and develop the facades, if we're not doing it correctly, then we are wasting our time. Facade systems these days typically go through rigorous testing. So a lot of the iconic projects that we've worked on over the years have gone through rigorous testing, whether that be for water, whether that be for air leakage, impact tests, thermal cycling. One of the things that people often forget is that with contraction and expansion of a facade system, you're potentially creating opportunities for water penetration, for air leakage. So these things have to be looked at and can be tested, and can be tested very thoroughly. You can see there in the video on the screen there, you know, this is it's a simple pressure test, a wind load test, and half the panels are just falling out of the building. You imagine if you'd put that onto a building without any testing and gone ahead with it, you would have a disaster on your hands, a complete and utter disaster. And that's why it's important that whereas, yes, we embrace the new materials, we embrace the glass, we embrace all the new technology that we can, we have to make sure that it complies with the requirements, that the facade functions the way it should. The air leakage is not an issue, that we don't have in the middle of a storm, in the middle of a heavy rainfall, that we don't have water seeping in to the building and causing us any problems and issues. So it's all about the function. It's all about the aesthetics. So changing facades. It's a short presentation just to give you a feel for about facades and how they've moved on and how we have a responsibility to ensure that facades function and not just look good. So yes, facades have changed. We all have a responsibility, not just for the aesthetics, but it's critical that we look at the functionality and the safety of the installed facade system. If we've not got it correct, if we haven't done our homework, if we've not done it right, we are going to have issues and problems. So thank you very much for listening. I will hand you to my esteemed colleague, Mr. Mutaz. Thank you very much.
Thank you, Julian. I'd like Mr. Mutaz Sahib to take over. He's going to talk about the designing of complex facade buildings and also the forensic on failed envelopes. Mr. Mutaz Sahib, for you.
Okay.
Yes, Mutaz, go ahead.
Thank you. Good afternoon, India. Thank you for having us. I'm Mu'taz Sahib, and I'm from Thomas Wright, and today I'll be talking about facade failures. As already a lot of you know, we're Thomas Wright. We're an independent professional firm specializes in the facade consulting, curtain wall testing, and fire testing and certification. We have 27 years of experience. We have more than 100 employees. We have 15 nationalities. We have 200 completed projects for the consulting department only. And we have 700 plus clients. Mostly they're happy. Okay, in consulting department, we offer 3 main packages. Today we'll talk about facade failures, which is under the investigation, forensic investigation and special inspection department. Okay, I want to start with a story. One day, on a summer day, GM customer service received a complaint from a customer saying, my Pontiac is allergic to vanilla ice cream. They laughed. They thought that this cannot be real. How come a car can be allergic to vanilla ice cream? The problem is, according to the customer, is whenever he orders an ice cream, a vanilla ice cream, the car won't start. And whenever he orders any other flavor, the car will start. So one of the engineers took this as a serious complaint and he investigated, and it turned to be something called a vapor lock issue, and GM redesigned the fuel delivery system to resolve the issue. My point on this one is sometimes the problems are packaged according to the customer's point of view. Keeping this in mind, this will help us to better understand the studies that will be presented after, so that we understand how sometimes each investigation is unique in the way you tackle it. So, what is facade failures? Okay, there are a lot of definitions for facade failure, but the short one is the inability of facade material or support to function properly, fail, or pose a risk. Now, function might be an aesthetic, structural, weather tightness, acoustic, fire, etc. There are some risks that is associated with facade failure. It could pose an injury or life risk, loss of revenue, sick building syndromes, deterioration of the building structure or shorten the life of the building, costly repairs and maintenance, and sometimes it is not repairable. Today, I'll be presenting 3 case studies. However, due to confidentiality, the project details, names, location cannot be disclosed. So you have to trust me on this one and believe for what I'm saying. The case studies are called codenamed the Villa, the 50+ Tower, and the Unrectifiable. Okay, there are several things that are in common for all these investigations. All the projects in this investigation, they had 2 facade consultants already that reviewed the drawings. Rectification work sometimes involved removing complete facade units, and this is an expensive investigation. I mean, imagine having 5 engineers working for 10 to 15 days, sometimes 20 days, putting ideas and what caused this one and turning each nut and bolt and trying to find an answer for what went wrong. For case study number 1, the Villa, we received an inquiry. It was a very simple inquiry. Mold and mildew on wood. The wood is very expensive. Apparently, it was sourced from the Scandinavian countries, and it is specially treated for a VIP client. So we proposed several actions to be taken in order to address the issue. So we proposed thermography scan, review of drawing specification materials. We also recommended to have air infiltration in order to quantify if there is a leakage that might cause condensation. Then we offered site inspections. Then we ended up brainstorming and report. For people who are unaware of thermography, this is a thermography. Basically, it measures the temperature of various surfaces. So whenever you see red, that means this is a hot air coming from outside to the air-conditioned space. Again, whenever you see, now it is expected to have hot air coming from around the glazing, because this is the entry point usually of all the glazing. It is a weak point. Again, you can see the red around the glazing. This one is the exact opposite. This is cold air escaping from the inside. So basically, this picture was taken from the outside, and you can see the cold air, which is in light blue, escaping of the unit. Now, upon close inspection and review of shop drawing, we discovered several faults in the fabrication, installation, and design. The major 2 design issues were that this system heavily relies on a brush instead of gaskets, which does not offer the sealing properties of a gasket. So the brush is only to be used on a low-profile housings and should not be used in a villas or palaces that are in the island. The other major fault that we found is that drainage is below the finished floor level, and there's no way actually for water to escape. In addition, we found several faulty details. I mean, if you look at the detail at the left, there is no insulation, no thermal insulation. There is no proper sealing. This will allow lateral heat to go from the GRC directly into the wood finish, and it will cause condensation and it will cause mildew. On the right hand, you can see an opening, daylight from the unit. This is actually a picture from the inside. You should not see a daylight from inside. This indicated a poor fabrication and a poor installation practices. Okay, so what did we learn from this one? Thermography scan and air filtration indicated excessive air leakage. We've already known that. Review of drawings indicated faulty interface details and thermal insulation was placed in the wrong location and sometimes it was missing. Site inspection indicated poor fabrication and installation practices. So what was our recommendation? Unfortunately, the recommendation was the majority of units should be replaced. It was at a cost of 1.1 million dirhams, which is equivalent to almost $300 USD. Case study number 2, the 50+ tower. The inquiry that we received was multiple insulated glass units failure plus 203 cases of IGU disengagement from the building envelope. As most investigations action plan, we started with review of drawings, specifications, calculation, materials, etc., review of compatibility certificates, site inspections, brainstorming, and finally the report. The starting point of any investigation is always to try to find a pattern, a frequency, location, and facade orientation, time frame of failure, unit type, etc. Facade failure investigation is usually done by either traceability of cause and effect association or elimination and exclusion of probable causes. From the inquiry and preliminary analysis, it was very evident that this is a sealant failure issue. As seen in this slide, TBWIC have established most probable issues and processes that might have contributed to the IGU failure in order to eliminate probable suspected items and or procedures during all project phases, from procurement all the way to final handing over. The magnitude and location of failure rate indicated the cause of failure is a repetitive consistent through the 3 years of glazing fabrication. Since different batches of glazing and sealants were used over 3 years, product defects were eliminated from the list, such as expired material, faulty batches. You cannot have the same faulty material for 3 years without somebody knowing about it. Furthermore, processing of the insulated glass unit spanned over 3 years. Therefore, it is almost impossible to have the same processing fault contamination for such a long duration. Therefore, processing fault as a primary suspect of debonding was eliminated. A systematic process such as sealant mixing ratio is not possible for the complete processing period. However, since the stick glazing units were fabricated at the same time at the same premises and using the same material without reported a faulty fabrication or material, without reporting any issues, faulty fabrication or material are very remote causes of this IGU failure. Based on the gathered data for almost 4 weeks, it is clear that the failure caused is inherent to material used and how it all reacts together. So what caused this catastrophic failure with such a magnitude? In order to understand what really happened, we need to understand the following details. The detail on the left is the IFC, which is issued for construction drawing, which is usually provided by the consultant. The blue box is the structural silicon supporting the glass unit to the aluminum frame. The second blue box is the secondary sealant that hold both glass panels. And the red strip is the aluminum profile that provides protection for the glass. Plus, it provides proper sealing detail. The detail on the right is the detail that was proposed by the contractor. It had almost the same elements as the structural sealant that's holding the IGU and the secondary sealant, and offered and instead of aluminum profile, the contractor proposed an EPDM. The EPDM provided the better thermal break properties than the aluminum. However, it had a major design flaw. The EPDM and used sealants are not compatible. The incompatibility caused the chemicals inside the EPDM to attack both sealants and was the main reason for such a catastrophic failure. So what did we learn from? Despite the fact that the contractor proposed a better details in terms of thermal performance, it had a major design flaw. They say the devil is in the details, and for this case, unfortunately, it was very true. Compatibility testing of various items in contact with chemicals is a necessity and not luxury for all facade elements. From experience, we can say the compatibility issues usually constitute approximately 20% of all building envelope glass failure investigations. The final recommendation for such a catastrophic failure was to replace all the glazing unit at a cost of $6.5 million US. This was easier said than done since the building was already occupied and operational. This is the end of case number 2.